Have you ever had such an experience? You were casually handling a magnet when, unfortunately, it slipped from your hand and dropped to the ground. Upon picking it up, you were surprised to find it had broken into two pieces. What's even more bewildering is that when you try to rejoin the broken parts, an invisible force at the fracture seems to strongly resist, preventing the two pieces from fitting back together seamlessly. You might be a bit confused at this time. Why did this magnet, which looks as hard as an iron block, break so easily? It was still a complete magnet not long ago. Why can't it be put back together after being broken? Regarding the first question, it is necessary to make it clear that the magnets used in daily life are usually artificial magnets. Among them, the most common ferrite magnets and neodymium magnets both adopt the manufacturing process of powder metallurgy. It is a manufacturing method that grinds multiple raw materials into fine powders, then fully and evenly mixes them, and finally forms them by sintering. This precise control of components avoids local differences in magnetic properties caused by uneven components, making the overall magnetic properties of the magnets more stable and excellent. However, there are also some problems with this process. During the sintering stage, even if efforts are made to optimize the process flow, due to multiple factors such as the characteristics of powder particles and limitations of sintering conditions, numerous tiny pores will often inevitably form inside the material, which reduces the overall strength of the magnets. Therefore, when the magnets are subjected to external forces, such as collisions and impacts, they are extremely prone to breakage and damage. So, why is it that some magnets can't return to their original state after they are broken? Before understanding this issue thoroughly, we must first know where the magnetism of a magnet comes from. Artificial magnets don't possess magnetic force right after being molded. Only after being magnetized can they become real magnets. Before the magnet is magnetized, the arrangement of its magnetic domains is disordered. Although each individual magnetic domain area has magnetism, the different magnetic field directions cause their magnetic forces to cancel each other out. During the magnetization process of a magnet, a directional strong magnetic field will be applied externally. This external strong magnetic field causes the originally disordered magnetic domains inside the magnet to become uniformly aligned in the same direction, thus transforming it into a magnetic magnet. After the magnetization is completed, the alignment direction of the magnetic domains inside the magnet will be basically consistent with the magnetization direction applied externally. And this direction also determines the distribution of the magnetic poles of the magnet. Take the bar magnets commonly used in our daily life as an example. If the magnetization direction is along the length direction, then the south pole and the north pole will be formed at its left and right ends respectively. From the basic physical property of magnetic fields, they have two key features: continuity and closure. Magnetic field lines have definite and constant paths. They start from the north pole of a magnet, extend and converge to the south pole. Then, they return within the magnet in the opposite direction back to the north pole, forming a complete closed loop and maintaining the stable and orderly state of the magnetic field. When this magnet breaks and the fracture surface is perpendicular to its magnetization direction, the magnet will spontaneously reconstruct the magnetic poles at the fracture position. This is because the magnetic field needs to maintain its complete closed and continuous state. After the distribution pattern of the magnetic field lines of the original magnetic field is disrupted, new magnetic poles will inevitably be generated at the newly formed fracture surface, so as to ensure that each individual piece of the broken magnet can construct an independent and complete closed magnetic field line loop. In this case, since the magnetic poles generated on the fracture surfaces are different, there will be an attractive force between them. We can use glue to stick the two pieces of magnets together again at the fracture to repair it. Conversely, if the magnetization direction is along the thickness direction, then the south pole and the north pole will be formed at its upper and lower ends respectively. This kind of magnet has a larger usage area and can absorb and fix objects very well. We also break it in the middle, but its fracture surface is parallel to the magnetization direction. In this case, the path of the magnetic lines of force inside the magnet is not blocked, and the magnetic field can still maintain its original continuity and closure. Therefore, neither of the two separated magnets will form new magnetic poles at the fracture surface. Since the two magnets have the same magnetic poles at the fracture surfaces and repel each other, these two magnets cannot be put back together at the fracture. Some of the magnet products we use in daily life and the magnets removed from electronic devices are mostly magnetized in thickness. When they break, the fracture surfaces are mostly parallel to their magnetic field directions. This is also the reason why people generally think that magnets cannot be put back together after being broken. Certainly, the reality could be more complicated. The fracture surfaces might turn out to be completely irregular in shape. Such complex magnetic pole distributions will cause the magnetic force interactions at the fracture sites to become chaotic. When the broken surfaces of two magnets are brought close to each other, it's quite probable that some parts will attract each other while others will repel. This also makes it rather difficult to put the magnets back together. That's all for today. Thank you for watching. If you enjoyed it, don't forget to like and subscribe to our channel. If you're interested in our permanent magnet products, please contact us. See you next time.